What's up, everybody? So this isn't actually a part in the series. This is just me answering a few of the comment questions that people have been asking. One of the ones I've gotten was how to make a O2 spacer for your headers, and I'm just going to draw it out on the board because I don't really want to spend the money to go make it, and I don't have a tap and die set anymore. But it's a pretty easy step-by-step explanation. Whenever you see it on the board, you'll go, oh, that's how you do it, and then, you'll be fine. So I hope I drew this big enough for everyone to see. Basically, this drawing is what you're looking for in an O2 spacer. This is a threaded outside insert that has the same thread pattern as your O2 spacer. And this is a sleeve with threads on the inside that is the same thread pattern as your O2 spacer. So you can screw your O2 spacer into this and then screw this into your headers, which is what obviously spaces it out. Be sure to include a hole here. That's to let just a little gas through so it's actually picking up something. But without the hole, you're going to have the same problem as if you just put your thing in there like that. You'd be very lucky to actually find an O2 spacer like this ready-made that you can just go and screw in. What you're more likely to find is one like this, where it has the correct thread pattern on the part that goes inside the header, but the inside is a much smaller thread pattern than what your oxygen sensor is. So this is why you need the tap and die set. What you do is you then take your drill, which assuming you have a tap and die set, I'm guessing you have a drill too. You take your drill and you drill this out so that it is the correct diameter for the tap that you need to use for your O2 spacer. The question then is, well, how do you find what the thread pattern is for your O2 spacer? Well, I'd say about 98% of O2 spacers you're going to come across are made by Bosch. And Bosch makes only 2 or 3 different types of spacer. So you just go in and you look at whatever the specific Bosch number is, and then you can just find the thread pattern on Bosch's website. They'll tell you right away if you ask them. So then you just take your tap and die set, drill it out, and tap this, and voila, you have what you're looking for. There is one more way you can make your own oxygen spacer, but this way requires that you have more supplies and you know how to weld, and you're just more capable with machining and metalwork. So what you can do is you get a plug, like an exhaust plug. They make these. You can get them at any auto parts store, and they're all hollow on the inside here. So what you're going to need to do once you get it is you're going to immediately need to drill a hole right here so you can have the gases flow a little bit. It doesn't need to be a very big hole, but it just needs to be, big enough, maybe a little bit bigger than a 1/4 inch hole. And then you take a piece of pipe that you just have lying around, or you can get it at you can get it really anywhere. A lot of places will give you a little small piece of scrap for free if you just ask them. And then you take this, and then you drill it to the correct diameter and tap and die it, and then you get the correct thread pattern on the inside for your oxygen sensor. And then once you have this and this, you just weld them together. So you weld that to there, and voila, you have what you're looking for once again. But this is a little bit more convoluted way of doing it. This is like more of a way if you just happen to have your own shop and you have some of these parts laying around. It's just an easy way to do it if you know what you're doing. So this is just going to be a quick little review again of how a strut works. I don't think I did a very good job in my video where I explained how it works. So this is a front axle without a strut bar. I'm just going to explain how it kind of acts going around the corner, and then I'm going to explain how it acts when it has a strut bar on it. Let's look at the example without a strut bar first. So let's pretend that the car is coming towards you and it's going to make a turn in this direction. Now what's going to happen when it's going around the corner is the weight transfer is going to shift a lot of weight this way on the car, which is going to put a lot of pressure on this wheel, a lot of downward force, which is going to create this spring to retract. So it's going to obviously compress this, and it's going to get lower on that side. But conversely, what happens is this side starts to raise up as this side starts to go down. So you're losing traction on this side of the car as you're gaining traction on this side of the car. And it's not entirely proportional. You're losing more traction actually than you're gaining over here. And that's kind of the problem with not having a stiff front axle when you're going around the corner. Alright, and this is the case with the tower strut brace. Again, we're pretending that the car is coming towards you and still turning in this direction. So, like before, a lot of weight is being transferred in this direction, and therefore creating a downward force on this tire and making the suspension sag, and you get more traction over here. But, unlike the case where there was no tower strut bar, there is actually something holding this tire down from going up. It's this bar. Because this bar is rigidly mounted, as this gets pushed down, it also pushes down this tire. So you're actually getting a little bit of force downward on this tire as well, increasing traction over here, as well as increasing traction over here. So you're actually increasing traction over the whole time instead of losing it where you were before without the tower strut brace. I hope those couple brief explanations answered most of the questions you were having in the comments. If you have any more, feel free to comment, let me know. I'll make another one of these videos explaining how things work a little bit better. Thanks for watching. See you next time.